Hello and welcome to Wired and Wireless Networks Lesson 3. We're going to keep going with our journey through the exciting world of network protocols. Today we're going to be concentrating on TCP and IP. As we've seen, there are a lot of protocols you need to know for this syllabus, but TCP and IP are two of the most important. Why are TCP and IP two of the most important? Well, TCP/IP protocols are the backbone of the internet. The TCP/IP suite is made up of two protocols used together to make sure the data we send ends up present and correct at the right computer. TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. Transmission Control Protocol. What does it do? Well, you can't send huge blocks of data, huge messages across a network. It ties up routers, it ties up the network infrastructure. It's not a good way of doing it. It's much more sensible to divide the data into small units that we call packets. And that's the first job of TCP. Take all your data, divide it into smaller packets.
Likewise, for the internet to work efficiently, this web page is pulverized into thousands of tiny packets of data, each one wrapped with all of the information it needs to rebuild itself in England.
Each of these packets of data is made up of a header and a payload. Payload is the actual data that you're trying to send, and the header is kind of the metadata, the data about the data that you need to include. So that may include something like the sequence number of the packet, so it can be put back together at the other end. It may also include a checksum. A checksum is just a way of making sure that all your data gets there correctly. You look at all the ones and zeros, you perform a mathematical calculation on those ones and zeros, and you get a number that is the answer. And you include that in the header along with that packet. At the other end, the receiving computer can perform the same calculation on all the bits in that packet. Does it get the same number? If it doesn't, something's gone wrong, the data's been corrupted, and it can ask for it to be resent. And as I said, the payload contains all the data from the application that needs to be sent. So that could be part of a request for a web page, it could be part of an email, whatever. At the other end, when receiving data, TCP examines packets for errors, could try to fix errors, look for missing packets. If it finds anything that's gone wrong, it can ask for packets to be resent, and then uses the sequence number to reassemble the original message, the original data, in the correct order. What about the Internet Protocol? Well, when you send data on the internet, it passes through many computer networks on its way to the destination computer. Remember, even when you're dealing with the internet isn't just one network, it's all these different wide area networks put together. So the IP layer, the Internet Protocol layer, is responsible for addressing packets of data, and that's adding onto them a destination address and a source address. The Internet Protocol defines how data packets should be sent between networks. An Internet Protocol header is added to each data packet containing the source and destination address for that packet, and routers use this information to determine whether the packet's destination is its own local network or whether the packet needs to be passed on to another network on its journey to its final destination. So if you look at all that together, you start with your original piece of data. The TCP software, it's usually built into your operating system, takes that data, divides it into little message packets, adds some header information to that, passes it down to the Internet Protocol layer software, which then adds the source and destination address, and that then sends it on to the next leg of its journey, and eventually it'll pass through all the different points on the internet, gets back to their end, source and destination addresses get stripped from it, all the packets get reassembled into the correct order, and then whatever application needs to deal with that data gets sent the data as the final stage. So again, it's very important to note that when we send data across a network, it gets sent by all kinds of different routes. You can't just send one big block of data through one route because you tie up too much of the connection. You divide the data into little pieces and you send them from router to router to router, from network to network to network across the internet, and each packet of data can take a completely different route, but they all get reassembled eventually at the right recipient computer, And that is basically how data is transmitted across a wide area network. So this is why every computer online has what is known as an Internet Protocol address. So for example, we like to use the human readable domain name, the address like www.facebook.com, but that doesn't really mean anything for the computer. That's just a human readable form for us. What the computer is interested in the IP address like 31.13.90.2. That is how to actually find that computer with the information on a wide area network. For a long time, we used Internet Protocol version 4 all the way from the early 1980s, and it is still being used. Internet Protocol version 4 uses a 32-bit number to address each packet of data. The address is broken down into 4 8-bit sections, each of which represents a number between 0 and 255, separated by a full stop. So classic example, something like 194.83.249.5. And that is what an Internet Protocol version 4 address looks like. Now, as it is a 32-bit number, you get 2 to the power 32 possible different variants, and that gives you about 4 billion addresses. Now, when Internet Protocol version 4 came about, we never thought we would need more than 4 billion addresses. But if you think about that, is that enough today for every single different device that is connected to the internet? Well, the answer is no, because IP version 4 addresses actually started to run out all the way back in 2011. We just simply had too many people and too many devices needing to connect to the internet. So what did we do? Well, we launched a new version called IP version 6. IP version 6 has been in the works for quite a long time, but swapping from one version of the Internet Protocol to another is really complicated because you've got to change the complete addressing system of millions of computers and millions of routers all around the world. So IP version 6, who knows what happened to IP version 5? We just skipped over it. But this is a 128-bit addressing system, which means it is divided into 8 16-bit sections. The addresses are written using hexadecimal, and as each hexadecimal number represents 4 bits, there are 4 numbers to each section or group, and each section is separated by a colon. So we've got an example here. You can see it's got numbers and hexadecimal letters, and that is a 128-bit addressing system, so it has 2 to the power 128 possible variations, which is around 340 trillion different addresses, which is quite a lot. So hopefully we won't need to move on to IP version 7 or IP version 8 for some time. At the moment, we're using both IP version 4 and IP version 6 at the same time, but in a short time, in a few years, we'll probably look at phasing out IP version 4 and just having IP version 6. So when we talk about IP addresses, it's also useful to mention MAC addresses, something that we might have covered before, you might have come across before. A media access control address, a MAC address, nothing to do with Apple Mac computers, something different, is a unique number that identifies the actual device that is connected to a network. The MAC address is usually hard-coded into a network interface card inside the device and is assigned when the NIC is manufactured and cannot ever be changed. So in the old days, we would have a card like this that we would slot into our computer systems. Nowadays, it's just a chip on the motherboard, which can be built into your tablet or your mobile phone or any other device. A MAC address is used to route frames of data around a local area network. Okay, so we use the MAC address for the local area network. So again, your MAC address is for a local area network. The IP address is for a wide area network, such as the internet. Bit of a simplification, but that's all you need to know at this level. Summary: TCP IP is the backbone of the internet. TCP divides data into packets, adds sequence numbers, and handles error checking. The Internet Protocol addresses packets of data with both a source and a destination address. Please don't get confused between IP addresses and MAC addresses. IP addresses are for wide area networks, and MAC addresses are for identifying individual devices on a local area network. So even though we've covered a lot of network protocols, we're not quite finished. We've got all the lovely email protocols to cover, and that will be done in my next lesson. Good luck, have a great time, and good luck with your studies.